NENOMATICA, where mathematics meets YouTube excellence. We start with the first example. The equation is 3 over the quantity 3x squared minus 3x minus 28 equals 5 over the quantity 5x squared minus x minus 20. Step 1. Move all terms to one side to set the equation equal to 0. Step 2. Combine into a single fraction using the common denominator. Step 3. A fraction equals 0 if, and only if its numerator is 0 while the denominator is not 0. Step 4. Expand each product exactly as shown. Combine like terms to obtain a linear equation. Step 6. Solve the linear equation for x, then reduce the fraction. Step 7. Domain check. Ensure the original denominators are not 0 at the solution. 2 over x minus 3 minus 3 over x plus 3 equals 12 over x squared minus 9. Step 1. Rewrite the equation with a common denominator on the left and move all terms to one side. Note that x squared minus 9 factors as x minus 3 times x plus 3. So we write 2 over x minus 3 over x plus 3 minus 12 over open parenthesis x minus 3 close parenthesis open parenthesis x plus 3 close parenthesis equals 0. Step 2. Combine all terms over the common denominator x minus 3 times x plus 3. This gives the single fraction with numerator 2 times x plus 3 minus 3 times x minus 3 minus 12. Step 3. Expand the numerator using distribution. 2x plus 6 minus 3x plus 9 minus 12 all over the same denominator equals 0. Step 4. Simplify the numerator by combining like terms. 2x minus 3x is negative x. 6 plus 9 minus 12 is 3. So the numerator becomes negative x plus 3. Step 5. A fraction equals 0 if, and only if its numerator is 0, while the denominator is not 0. Therefore, set the numerator negative x plus 3 equal to 0, and note the restrictions x not equal 3 and x not equal negative 3. Step 6. Solve the linear equation. From negative x plus 3 equals 0, we get negative x equals negative 3, so x equals 3. Step 7. Verify the candidate. When x equals 3, the denominator x minus 3 is 0. That makes the original fractions undefined. Hence, x equals 3 is not an acceptable solution, and therefore the equation has no valid solutions. Step 1. Apply cross-multiplication to the equation. Multiply 3 times the numerator on the left and 1 times the denominator on the right. Step 2. Distribute multiplication over addition on both sides. Notice that each side becomes the same linear expression. Step 3. Subtract 15 from both sides. The equality reduces to 3x equals 3x, an identity. Step 4. Interpret the identity. Because both sides match, the equation holds for all real numbers that keep the original denominator non-zero. The domain restriction is 3x plus 15 not equal 0, which means x is not equal to negative 5. Therefore, the solution set is all real numbers except negative 5. Step 1. Add each denominator to its numerator on both sides of the proportion. This keeps the equality true and avoids generating a fourth-degree equation later. Quick challenge. Can you spot exactly what changed from the previous line? Step 2. Simplify the new numerators by combining like terms. Both sides simplify to the same trinomial. Step 3. Since the numerators are equal and non-zero, we can divide both sides by that common factor. This yields 1 over each denominator. Step 4. If 1 over a equals 1 over b, then a equals b. Equate. Step 4. If 1 over a equals 1 over b, then a equals b. Equate the denominators to get a quadratic that simplifies to a linear equation. Step 5. Subtract x squared from both sides and solve the resulting linear equation. Great work! Let us celebrate the final answer. The solution is x equals 17. This method avoided unnecessary fourth-degree algebra. Step 1. Substitution. Replace x with 2 everywhere, then simplify only by substitution. Step 2. Rearrangement. Move everything to the left side to set the equation equal to 0. Step 3. Combine like terms. Combine the 2 half denominators into a single fraction. Quantity a minus 2 over 2 minus I over 2 equals the difference over 2. Step 4. Simplify the constant fraction. Negative 2 over 2 equals negative 1. Step 5. Isolate the fraction by adding 1 to both sides. Step 6. Cross multiplication gives 2 equals a minus 2. Step 7. Add 2 to both sides to get it equals 4. Example. We will find the value of k that makes t equals negative 3 a solution of the equation. The equation is open parenthesis 4 minus t, close parenthesis over open parenthesis 2 minus 2t, close parenthesis equals open parenthesis 3t squared plus k, close parenthesis over open parenthesis t squared plus 1 close parenthesis squared minus 68. Step 1. Substitute t equals negative 3 into both sides. Step 2. Evaluate powers and simplify. Negative 3 squared is 9. 4 minus negative 3 is 7. 2 minus 2 times negative 3 is 8. Compute 3 times 9 equals 27, and 10 squared equals 100. Then 100 minus 68 is 32. Step 4. Cross multiply to clear the fractions. 7 times 32 equals 8 times the quantity 27 plus apply to clear the fractions. 7 times 32 equals 8 times the quantity 27 plus k. Step 5. Compute the products and solve for k. 7 times 32 is 224. Distribute the 8 to get 216 plus 8k. Move 216 to the left to isolate 8k. Divide by 8 to find k equals 1. Quick check. Substitute k equals 1 into the simplified proportion to confirm. 7 over 8 equals 27 plus 1 over 32, which is 28 over 32. And indeed, 7 over 8 equals 28 over 32. So, k equals 1 is correct. Final answer. The value of k that satisfies the equation for t equals negative 3 is k equals 1. Example. We will solve the fraction equation exactly following the shown algorithm. Problem statement. If we increase the numerator by 2 and decrease the denominator by 2, the fraction remains equal to the original fraction. Write the equation and find the original fraction x over y. Step 1. Write the equation for the equivalent fractions. Step 2. Use the cross multiplication property to eliminate denominators. Step 3. Apply the distributive property on both sides. Step 4. Subtract yx from both sides to isolate the remaining terms. Step 5. Express x over y by dividing both sides appropriately. Step 6. Simplify the right-hand fraction to lowest terms. Final answer. The original fraction equals negative 1 over 1. Quick challenge. Verify by substituting x. Example. We will solve the ratio equation from the image exactly as written and follow the same step order. Our given information is y equals 1, and the ratio x plus 1 over y minus 2 equals 1 minus x over y plus 2. Step 1. Substitute y equals 1 into the given ratio equation. Step 2. Simplify both denominators. 1 minus 2 equals negative 1, and 1 plus 2 equals 3. Step 3. Cross multiply to remove the fractions. Step 4. Apply the distributive property on both sides. Step 5. Collect like terms to isolate x. Step 6. Isolate the variable. Subtract 3 from both sides, then divide by 2. Great work! The solution is x equals negative 2. Quick challenge. Verify by substituting x equals negative 2 and y equals 1 back into the original ratio. Example. 2 taps A and B fill 1 pool. Tap A fills the pool 10 hours faster than tap B. If we open both taps together, the pool is filled in 12 hours. If only tap B is open, in how many hours will the pool be filled? We'll solve step by step using a clean rate equation. Let's visualize the situation. We'll draw the pool and 2 inlet pipes, A on the left top and B on the left bottom. We'll keep them connected to the same pool, so their rates add when both are open. Step 1. Assume tap B fills the pool in X hours. Step 2. Let V be the pool volume, so B's rate is V over X per hour. Step 3. Since A is 10 hours faster than B, A needs X minus 10 hours alone, so A's rate is V over X minus 10 per hour. Step 4. When both taps are open, their rates add. The pool fills in 12 hours, so the combined rate equals V over 12. Therefore, V over X plus V over X minus 10 equals V over 12. Step 5. Divide both sides by V to simplify. We obtain 1 over X plus 1 over X minus 10 equals 1 over 12. Step 6. Solve the equation. Multiply both sides by 12x times X minus 10. That yields 12 times X minus 10 plus 12x equals X times X minus 10. Simplify to 24x minus 120 equals X squared minus 10x. Move everything to one side. 0 equals X squared minus 34x plus 120. Factor X minus 30 times X minus 4 equals 0. The roots are 4 and 30, but X equals 4 would force A to need negative 6 hours, which is impossible. So X is 30 hours for tap B. Then tap A needs X minus 10 equals 20 hours. A quick check. 1/30th plus 1/20th equals 1 over 12. Perfect. In this example, we solve a classic fair sharing puzzle using algebra. Example: a cake was divided equally among some people. Then one more person joined, and the cake was divided again. At this stage, each person received 1/6 less cake than before. How many people were there at the beginning? Each person receives a slice worth 1 over n of the cake. After one more person joins, each share becomes 1 over n plus 1. The problem says the new share is smaller by exactly 1/6 of the cake compared to the original share. Original share minus new share equals 1/6 of a cake. That gives us 1 over n minus 1 over n plus 1 equals 1 over 6. Find a common denominator. The numerator becomes n plus 1 minus n, which is 1. So 1 over n times n plus 1 equals 1 over 6. Cross multiply to get n times n plus 1 equals 6. Expand to n squared plus n equals 6. Move everything to one side. N squared plus n minus 6 equals 0. Factor the quadratic. We get n plus 3 times n minus 2 equals 0. The possible roots are negative 3 and 2. Since the number of people must be positive, n equals 2. Quick check. If n equals 2, the first share is 1/2. With one more person, the new share is 1/3. 1/2 minus 1/3 equals 1/6. The condition is satisfied. Therefore, the cake was first divided among 2 people. After a third person joined, each person's piece decreased by exactly 1/6 of the cake. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.